Hey Damante, I pulled up your wrong answers. There are like 6 questions that you have missed so far. I want to go over these questions to see if I can help you with this. So here's the first question that you missed. Let's check this one out. In step 6, it is talking about two pairs of angles. So if we check these angles, we will have our answers actually. Angle FAD, start from F, go to A, and then D. The one in the middle is the angle. And then the second angle is angle EDB. Start from point E, go to D, and then go to B. So actually we are talking about this angle here and then that one here. These are called corresponding angles because they are looking at the same direction actually. They are both on the top right side of their points, of their vertices. So these are called corresponding angles. I'm pretty sure that the other one is going to be corresponding as well. So that's what this one would be, corresponding angles. So if you scroll a little, actually, there's this one here, corresponding angles, and then my screen is messing with me right now. Okay, and then D is also corresponding angles. So sorry about that. Let's check the next one. So it says we have two triangles that are congruent to each other. Let's see what the reasoning of this one could be. So what I realized at first, I have two pairs of angles here. That's the first one, the second one, and then there's one side. So the options are limited to two. This is the first one, and this is the second one. I need to see which one I had, because in step 6 and 7, I have one pair of sides and then two pairs of angles. So I already marked two of the angles that are congruent. Let's figure out the second pair of angles, ADF, given here. Point ADF is right here, that angle. And then point angle DBE is right here. Now, these two are the angles, and then if my side is DB, then it's going to be angle side angle because it's going to be a side that goes in between the angles. If it's not an included side, it's going to be angle side. Let's check step 7 out. It says side AD is equal to BD. AD is right here, BD is right here. So if you look at the pair, the blue angle and red angle has an included side in between them. So it would be this one right here. Corresponding angles, the first question's answer, and then angle side angle would be the second one. Okay, here is the second question that you missed out of 6. You missed 6 questions. This is the second one. So it says, place the steps proving that quadrilateral ABCD has congruent diagonals. So if you're going to show that the diagonals DB and the other diagonal are congruent. So first thing that I realized that looking at the figure, I see the right angles in the corners. So that must be my first step. That is the only thing that I see as given. So this means the figure is going to be a rectangle. So I look at the reasonings and then see which one has something related to 90 degrees or right angles. This one would be my first step. Notice that angle ABCD are right angles. So all 4 angles are congruent, which means the figure is going to be a rectangle. So ABCD is rectangle because of the right angles. That's my first step. So we are done with this. Next, I'm thinking about the question. I see this one here. Since ABCD is a rectangle, opposite sides are congruent. That should be my second step. Now that I know I am dealing with a rectangle, you cannot place it in the, like this, you cannot place this in the first step. I know that looking at the figure, you see that it is a rectangle, but you cannot just say that. You should say that the angles are 90 degrees, and that is your foundation to claim that the figure is a rectangle. So this would be step 2. That right here would be step 2. This would be step 1. Now that we know the opposite sides are equal, let me just put those marks over on the figure. Like these two are equal, and then the width are the same. By the way, the point of this question was showing that, let me just change this color, showing that the diagonals are congruent. The diagonals are DB and AC. That must be my last step. Like out of these 1, 2, 3, 4, 5 items, this, let me see, ABCD is a rectangle with congruent diagonals. This goes in the, this is going to be the last step. That is going to be the fourth step. And this should be the third one. Let's see the reasonings. Now that looking at the figure, I have two sides in here. That's the first one. This is the second one. And then there is a 90 degrees in between them. This reasoning is side and then the angle in the middle of the two sides. So it would be like side, angle, side. That would be the next step, which is step 3. So looking at here, that should be the step 3. Now that the triangles are congruent, I can move on to the next step. Let me see. Now that the triangles are congruent, their hypotenuse must be the same, such as, let me just change this color. Again, if the triangles are the same, all of the corresponding sides are the same. The corresponding sides are this one here and that one here. They correspond to each other. DB and let me see the name of the other one. I can see the other letter. DB and AC. So those should be equal to each other because now we know that triangles are equal. Their corresponding sides must be equal to each other. That would be my fourth step. Now, in the final step, I say I already knew that this was a rectangle, the whole thing, and then now we just figured out the diagonals are congruent. We would say ABCD is a rectangle with congruent diagonals. Okay, question number 3 is this one over here. You're gonna follow the flow in here. Let me just activate the screen right. We're gonna follow this pattern over here. We will do this and then we will go up, down. So if I'm looking for that question mark, its reasoning is gonna be due to the reason between these two. Like the relationship between these two is gonna give me why they are parallel. So looking at from two angles being corresponding angles, like here, if you have a corresponding angles being equal, and if it gives you that the figures are, the sides are parallelogram, my bad. When you have two corresponding angles or alternate interior angles or alternate interior angles being equal to each other, if your conclusion is two sides, two segments or lines being parallel to each other, like what we have in here in this step, then it would be like converse of corresponding angles postulate. Here is when you need to use that word converse. Let me just make this thinner a little. Okay, if you have two parallel lines, you must know that they are parallel. And these two angles are going to be equal because they are called corresponding angles. But you're gonna know that the lines are parallel. In this case, the reasoning would be corresponding angles theorem. If you have exactly the opposite of this, such as, let's just draw it over here, you have two lines, but you don't know for a fact that if they're parallel or not. You don't know that. But if you know that these two angles are equal right here in measures, then you say that because of the converse of corresponding angles theorem, the lines must be parallel. That's your conclusion, and the reasoning would be converse of corresponding angles theorem. Once again, if you know that the lines are parallel, such as here, the angles are going to be congruent because of corresponding angles theorem. If you have exactly opposite of this, where you have equal angles in measure, if you know that these two angles are equal, since they are corresponding angles, if they're equal, the lines are going to be parallel. That's going to be our conclusion, and the reason would be converse of corresponding angles theorem. Okay, we have these two questions, question number 4 and 5. So in here, in this step, it says we have substitution property. let's see how we have that. Usually substitution property is going to be about the two steps right before this, like step 2 and step 3. For substitution property, you gotta have the same measurements like this. On study island, substitution property and transitive property are the same. Like if you have one of them, you can name it either one of them, but you're not gonna have both of those options in one question. It's either gonna be substitution property or transitive property. But in here, we see that 180s are the same, so you can just do substitution and then get rid of them and then set up the other two equal to each other, such as measure of angle 1 plus angle 2 plus angle 3. This is step 3, must be equal to what we have in step 2, which is angle 4 plus angle 3. So if you look at in here, it's just left side is on the right, right side is on the left. So what they did, they set these two up equal to each other by doing substitution, because these expressions, both of these expressions are equal 180 degrees. You can just set them up equal to each other. It would be either called transitive property, or it would be called substitution property. They are both the same. Looking at the next question here. Okay, we have triangles being congruent. The possible reasons are side, 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 angle, angle, and angle, angle, side. Let's see what we have. So looking at these three steps, I have some sides and angles being equal. Probably my answer is going to have maybe two sides and one angle, or two angle and one side. It's going to be either one of these, I guess. So looking at step 3, QR and SP are congruent, which are these two sides. And looking at step 4, RS, which is right here, is congruent to SR, which is itself. So, and then in step 5, I have two 90 degrees angles. I'm going to mark those angles with another color and then see what kind of pattern I have. This is what you should do whenever you have a proof question. If segments are given congruent, just mark them on the figure. It would make it easier for you to realize what kind of pattern you have. If not, let me know what the problem is so I can better assist you. Right here it says angle PSR equals 90. Angle PSR is right here. Now I see what pattern I have. I have side, I have angle right here, and then side. So the answer of this would be side, angle, side. I don't know why you get this question wrong, because it's pretty easy. Everything is given. You just need to mark the sides and then angles and see what pattern you have. So let me know if it's still a problem. I'm going to move on to the next question now. Okay, first let's talk about conceptual meaning of this question. When it says prove it by contradiction, it means that assume that, like let's say I'm going to prove that 2 times 2 equals 4. Let's say this is what I'm going to prove. Or, my bad, let's say 2 times 2 is not equal to 5. Let's say this is what I need to prove. So what I do is assume opposite of this, such as it equals 5. Assume this, and then find a way to prove that this is a wrong statement. That's what proving by contradiction means. It's kind of confusing. So for this question, it is actually not. The given statement is angle 1 is not congruent to angle 2. We know this for a fact, like 100%. They give this to us. And then they want us to prove that ABCD is not a parallelogram. This is because, by definition, if it's a parallelogram, the opposite angles, like these two, must be equal. So as we go, in the end, if we show that these two angles are equal, we are going to be doing the contradiction part. We are going to be done, because it's going to be wrong. If we claim that angle 1 equals angle 2 in the end, that's going to be our contradiction, because we know that 100% that they're not equal. If we come up with that, that means whatever assumption we had at first is going to be proven wrong. So here, basically, logically, there's only one possible answer to this question, which is exactly opposite of this, which is angle 1 is congruent to angle 2. This is the only logical explanation. Like, That's the definition of contradiction, proving by contradiction. You do one assumption, you prove exactly opposite of what you assumed. So in here, that's our assumption, and we just put opposite of it. You don't even need to like think about the flow of the proof. So what you need to know is if there's a given statement, if there's an assumption, and if you're doing proof by contradiction, all you need to do is finding exactly the opposite of what the assumption is. Like opposite of this would be angle 1 is congruent to angle 2. So that would be your answer.